All right, today we are taking on more types of factoring variations. So first up, we're looking at grouping techniques. So first I'm looking at this expression right here, and I'm thinking, well, how do I factor it? Well, it's really close to being factored already. So we have x times this package of 2x minus 5 plus 4 times this package of 2x minus 5. So the fact that these two packages of 2x minus 5, the fact that they match, I can reorganize it by pulling the x plus 4 into its own group. So x plus 4 as a package times 2x minus 5. And that's really all I have to do. I'm factored already. So I'm going to go ahead and box it. Okay, one question that usually comes up from students is, well, Miss Crystal, did you lose the other 2x minus 5? And no, I actually didn't. So I want you to visualize something for a moment. If I was to put this into standard form, so look at the top structure. Here the x would have to be distributed over the 2x minus 5. So I see that x would multiply here and here. And then the 4 would be distributed over the 2x and the minus 5 as well. So there's really 4 multiplications that would take place. And if I go down here and I multiply it as a pair of binomials, it's really doing the same thing. Because here I would FOIL it out, the first, the outer, the inner, the last. So if I do my first, x is multiplied by the 2x. Okay, just like it is here. The outer, x, is multiplied by the minus 5, just like it was here. And then it's taking the 4 and doing the same thing. So here's that inside part, 4 times the 2x. And then here, the last part, 4 times the negative 5. So it's the exact same 4 multiplications that would occur if I was to put each of these into standard form. So these are truly equivalent structures. Okay, the next one, problem 2, I see that it is cubic. My highest degree is 3. And I see that there are 4 terms to it. So it's a cubic polynomial. And when there's 4 terms to it, I have to use a grouping technique. So I want to group the first 2 terms and the last 2 terms. So when I look at my first 2 terms here, I want to factor out a GCF, a greatest common factor. So they share in common an x squared. So I'm going to divide out an x squared. And then I'm leaving behind an x minus 10. Okay, and then I focus on the second 2 terms right here. And I'm looking for what do they share in common? What can I divide out? I can divide out a 3. And then what's left behind? Well, an x minus 10. So now I see that it's really in the same structure as it was over here. And these packages here and here, they match. So I can reorganize it. I can regroup it as x squared plus 3 times x minus 10. Okay, and that's as factored as I'm going to get. So I'm going to go ahead and box it. All right, next up, we're looking at more complicated quadratic trinomials. So we've looked at the basic type. Now we're looking more complicated. So here it's going to be in this structure, ax squared plus bx plus c. And I'm looking at that leading coefficient of a, and it's more complicated when that a value is not 1. So when I look at my first problem here in 3, I have 2x squared, right? It's not just x squared, it's 2x squared. So I'm trying to think, well, how can I factor this down? So if you do a guess and check technique, this is what you would do. So you make your 2 sets of parentheses. And that first term, the 2x squared, well, I know that it has to be an x and a 2x. There's no other option for what could multiply to 2x squared. So I'll put the 2x here and the x here. The order I place them, it does not actually matter. So now I'm looking at this last term, that negative 5. So I know that what goes here and what goes here has to multiply to negative 5. And there's only so many options. It has to be negative 1 times 5 or positive 1 times negative 5. Those would be my two options. So I need to figure out which one is it. So one way to kind of narrow it down is to visualize what has to be multiplied here and here to produce that 9x in the middle, the linear term in the middle. So I have to think which one makes sense. Should I put the positive 5 here, or the negative 1 here, or a positive 1, or a negative 5? Those are my options. It has to be one of those four. So if I need it to get me to a 9x, a positive 9x, I should see that right here would have to be the plus 5, because 2x times 5 would get me 10x, and then the negative 1 would go here, because negative 1 times x would be minus 1x, or negative x, right? It's the same thing. And if I add those together, that would take me back to the 9x right there. So using this guess and check method, I'm able to get there pretty quickly. I got 2x minus 1 times x plus 5. But I do know that using that technique can be challenging for some students. So I want to show you another technique. I'm going to show you a grouping technique. Let me write that, grouping. So here I'm looking back at that 2x squared plus 9x minus 5. And I want to picture that little cross right here. That's my product and my sum. And my product is the A times C, and my sum is the B in this structure. So my product has to be 2 times negative 5, which would be negative 10. So I'm looking for two numbers that multiply to negative 10. Product means multiply. And then my sum, here's my 9. They have to add to a positive 9. So two numbers that multiply to negative 10 that add to positive 9. So I should see, oh, well, it's got to be a 10 here and a negative 1 here. Okay, because if I take 10x and negative 1x, those would combine and get me the 9x that's in the middle right here. So I'm always focusing on that. Let me highlight that just to draw attention to it. All right, so now I need to use these two packages here. And I'm going to rewrite my expression here as 2x squared plus 10x minus x minus 5. So look at it right here. This part was here and here. The order doesn't matter, but I can see that together they would combine and take me back to that 9x right here. So now I have 4 terms, and I'm going to group my first two and divide out the GCF and do the same thing with the second set of 2. So I'm going to go here and then here. So over here, what's the GCF? They share a 2, they share an x, so 2x. What is staying behind? An x plus 5. Okay, over on the right, so over here, what do they share in common? A negative 1. What would be left behind? An x plus 5. So these two packages match, so I can regroup it and write it as 2x minus 1 times x plus 5. So I'm getting the same two factors that I saw over here. I just used a different method to get there. And it doesn't matter to me as long as you're able to break it down properly. All right, let's try that skill one more time. So here I'm looking at 3x squared minus 10x minus 8. So let me use that same strategy, guess and check first. So I have 3x squared right here. There's only two options that would work. It has to be a 3x and an x. For that negative 8, I really have 4 options. It could be negative 2 times 4, or 2 times negative 4, negative 1 times 8, or 1 times negative 8. Those would be my 4 options. Okay, but I know that here and here, whatever those products are, when I add them, it has to get me back to that negative 10x right here in the middle. So when I look at my numbers and I think of what's going to work, right, I really can't use the 1 and 8s, negatives or positives. It's got to be the 2 and 4, one of these two. So if I put a 4 right here, for example, and I put a 2 here, I can see that this will make 12x and this will make 2x. So I need to figure out my signs. I need it to be a negative 12x and a positive 2x, which means that the negative goes here, the minus goes here, and the plus goes here. So if I look at that just one more time, this would be negative 12x, this would be positive 2x, that would get me back to that negative 10x in the middle. So my factors have to be x squared plus 2 times x minus 4. Okay, and then I'm going to walk you through that grouping technique one more time. So I'm factoring the 3x squared minus 10x minus 8. So I'm looking at my cross, my product, my sum, a times c, and then the b. So 3 times negative 8 is negative 24. And then here we have negative 10. So I need two numbers that multiply to a negative 24 that add to a negative 10. And I should see, well, it's got to be negative 12 and 2. And when I put the x on both of those, I can see that negative 12x plus 2x will get me back to negative 10x right there. So these are my magic numbers that I'm going to use. So again, they combine and take us back to that negative 10x right there in the middle. So now I rewrite it as 3x squared minus 12x plus 2x minus 8. The order that I write these, it really doesn't matter. I will get the same end result. So I want to group the first two and the last two. I'm looking for a GCF here. I see it's 3x, leaving behind an x minus 4. Okay, over here I see it's a plus 2, leaving behind an x minus 4. These packages match. I can regroup it as 3x plus 2 times x minus 4. So I've just confirmed the same factorization, just using a different method. So again, it really doesn't matter to me. I'm just looking for, can you factor? I don't care what method you use. So whatever makes most sense to you is perfectly fine. All right, last type. So a perfect square trinomial. We talked about this with the basic type 2. We have two kinds. We have an x squared plus 2xy plus y squared variation, and an x squared minus 2xy plus y squared variation. So the first term and the last term are both perfect squares. And what's in the middle is taking the x times the y and doubling it. Here it ends up positive, here it ends up negative. The one on top factors into x plus y times itself. So really we write that as x plus y squared. The second one factors into x minus y times itself, which then becomes x minus y as a quantity squared. So whenever we have a perfect squared trinomial, it factors into a binomial squared, a binomial times itself. All right, so note that both of these are really more complicated quadratic trinomials, right? They're in that structure of ax squared plus bx plus c. So, and the a value is not 1. So I could go back and do this method, either one, for this type of problem. But I'm hopeful that you guys can see a pattern which helps you move faster. So when I look at problem 5, I can see that the first term is a perfect square, so is the last term. So my first term is 3x as a quantity squared, and my last term is a 5 as a quantity squared. So now, if I take 3x times 5, that's 15x. And if I double it, it gets me what's in the middle. So that helps me detect this as a perfect square trinomial. So then when I write it factored, I just write it as 3x plus 5 in parentheses squared. So a perfect square trinomial will always factor into a binomial squared. So a binomial times itself. Okay, in problem 6, I can see that this is really 2x as a quantity squared. And then right here, that 49 is 7 as a quantity squared, right? They're both perfect squares. The first term, the last term are perfect squares. So if I multiply 2x times 7, that's 14x. And if I double it, that gets me the 28x in the middle. So the one thing that's different here I saw it was a positive linear term, and here it's a negative linear term. So I know that this one will be 2x minus 7 in parentheses squared. So again, anytime that I see a perfect square trinomial, I can factor it using a different method, but I'm hopeful that you guys are able to see the pattern that emerges that just helps you move faster. So I'm able to see perfect square trinomial. It's going to factor into a binomial squared. So a binomial times itself. All right, that's all for today.